Today we learned statistics, chapter 8. We talk about the notes. Chapter 8 we learn is test, hypothesis test. We will use z-test, t-tests, z-test for the mean, and the t-test for the mean, z-test for proportion, chi-square test for variance and the standard deviation, and we will use 5 steps for hypothesis testing. Z-test for the mean is when sigma, population standard deviation, is given. We use Z. Sample mean minus population mean over standard deviation, population standard deviation sigma divided by square root of n. N is the sample size. If standard population standard deviation sigma is unknown, and we use sample standard deviation, use t-test. So it's the sample mean minus population mean over sample standard deviation divided by square root of n. Degree of freedom is n minus 1. For proportion, we always use z-test equal p hat is sample proportion minus population proportion over square root of p times q. Here q is equals n minus p divided by n, take square root. Chi-square test is the ratio between the variance of sample and the variance of population ratio divided s square over sigma square times degree of freedom n minus 1. And the 5 steps for hypothesis testing. First step, state the hypothesis, null hypothesis and alternate hypothesis, and identify which is the original claim. Second, find the critical values. Third, calculate the test values. Fourth, decide whether to reject or do not reject null hypothesis. And fifth, summarize the results. And following, find the critical z values for the following. A is alpha equals 0.5, two-tail test. So we draw a normal curve, two-tail test. Alpha is 0.05. So divided by 2, each tail is 0.025 on left and right. Since it is 0.05, so 1 minus 0.05, so confidence interval is 95%, 95%. So use the confidence interval on the t-distribution. Use this t-distribution confidence interval. It's t-distribution confidence interval is 95%. Figure out the z-score. So go down from 95%. You go down to the bottom row, the last row. Z-score equal 1.96. So that's the two sides. So it's a two-tail test. So one is positive on the right side. Z alpha over 2 is 1.96. Another one is Z alpha over 2 is negative 1.96. So this answer Z score is a positive negative 1.96. B use alpha equals 0.05. Left tail test. So the 0.05 totally go left tail. So alpha equals 0.05 on left. And use symmetric. So right tail is 0.05, symmetric, same area. Then we can figure out this confidence interval is 0.05, double is 0.10, 10%. 100% minus 10% is 90%. So looking for 90% confidence interval, this Z score. So we want left one. So 90% confidence interval. Look at the t-distribution, 90% confidence interval, go down to the bottom, z-score. 1.645. 1.645. Since this is the left tail test, so the z-score is a net 1.645. Net 1.645. And C, alpha equals 0.05, right tail test. So it's the similar like this. Alpha is 0.05. Total go to the right because right tail test. So alpha totally go to the right. So since it's symmetry, so this 0.05 add together is 0.10 is 10% and minus 100%. From 100% got 90%. So use confidence interval and similar like this one and figure out this side is 1.645. So this is positive 1.645, right tail. And D, it's alpha equals 0.01, two-tail test. So two-tail test, so you will use draw a normal curve divided 0.01 divided by 2. Each tail is 0.005 and right tail 0.005. So that's the two tail. So then 1 minus 0.01, you got 99.99. So it's 99% is a confidence interval. Then you can figure out, use confidence interval, you can figure out the two z-score. 99% confidence. So looking for this 99% confidence, go down to the bottom and figure out is 2.576. So this value, one negative, one positive, because two tail. So its answer is a positive negative 2.576. And E, left tail, alpha is 0.01. So 0.01 total go to the left. So this side is 0.01. Since it's symmetry, this side also, right side also 0.01. So between it, double is 0.02, so 2%. Subtract from 1%, so it's 98% confidence. So use 98% confidence interval. This 98% confidence, and down to the bottom, and you will get is 2.326. 2.326. Since this is the left tail, so its left side is negative 2.326. Now, if right tail, F, similar. If right tail is a positive 2.326. So this positive one. So that's question 2. And question 3. Question 3, given an average computer mouse inspector can inspect 60 mice per hour. So average mean, population mean is 60 mice per hour with a population standard deviation, which is sigma, equal 14 mice per hour, And the 50 computer mice inspectors, n equal 50 mice inspectors at a particular factory can only inspect 53 mice per hour. So average for 50 inspector, and then average figure out is 53 mice per hour. So X bar is 53. So those are given condition. And the question asks, does the company have reason to believe that these inspectors are less than the average at alpha equals 0.10. So alpha is equal 0.10. That's given. So want to figure out less than 60. So if I have a less than, if no equal sign, put in the alternate hypothesis, H1. H1 is mu, less than 60. That's original claim. And the null hypothesis, you can put greater than or equal 60, or you just can put equal. For equal sign, put in null hypothesis, H0. That's the first step. You have to figure out this hypothesis. Which one is H1, which one is H0. And then, so then we are looking for the critical value. Since according this is less than, this less than, this less than, point to the left. So the alpha 0.10 totally go to the left. Go to the left. So this area is 0.10 is alpha. Alpha equals 0.10 is this. Since it's symmetric, the right side, right tail also 0.10, which is 20%. Add together 0.20, 20%. Subtract from 100%. So between it, confidence interval is 80%. So you will use 80% confidence interval. Here, 80% confidence interval. Go to the bottom, find the z-score is 1.282. Z-score is 1.282. And here is one left side, because pointer point to the left is left tail test. So it's negative 1.282. So this critical value is negative 1.282. Then find out the test value. Test value is used because sigma population standard deviation is given. So use z-score. Use z test equal sample mean minus population mean over standard deviation divided by square root of n. Sample mean is 53 minus population mean is 60, and over population standard deviation 14 divided by square root of n is 50. And figure out this one, this divide, you reciprocal, so square root of 50, multiply on the top. Cancel, you will get negative 3.54. And since negative 3.54 is less than negative 1.282 is falling critical region, is to the left. Negative 3.54 is less than this critical value. Negative 1.282 is falling to the left. It's on the left of critical value. So it's falling in this critical region is also called rejection region. So falling in critical region. So that means reject H0 and support H1. So this evidence sample is support H1, original claim. So yes. So question is lower than the average. So is that have reason to believe that this inspector are slower than the average? Yes, because the test value negative 3.54 falls in the critical region, will reject H0, support H1. So this side on the critical region will reject H0, support H1. So yes, it is support H is have reasonable reasons believe that the inspector are slower than the average. Then question 4. Dr. Christina Carterman, a nutritionist, claims that the average number of calories in a serving of popcorn is 75. So mean claim. This is a claim. Population mean is 75 calories, and the standard deviation, population standard deviation is 10. Sigma is 10. So this uses z test because sigma is given. Sample is 50. N equal 50 serving of popcorns was found to have an average sample 50 and sample mean 78. So X bar is 78 calories. Check the claim. What's the claim? Dr. Carter claim. Claim is the average of number of servings is equal. 75. That's the claim, which is equal. So your null hypothesis, H0 is mean equals 75. That is the original claim. That's the claim we want to decide. This is the claim. And the other one, H1, should be not equal 75. So alpha is 0.05. Significance level is 0.5%. Significance level. So we go draw this Bell's normal distribution curve. And here is the two side. This is a two-tail test because I have a not on H1 alternate hypothesis not equal is a two-tail test. So population standard deviation is norm, which is sigma is norm. So use z test. Critical value for a two-tail test, alpha equals 0.05. Alpha equals 0.05, two-tail test, you divided by 2. So this side is 0.25, the other side is 0.025. Add together is 0.05. It's alpha over 2 is each tail. So figure out this z values. So the 100% minus 5% is confidence interval is 95%. So use 95% confidence interval. 95% confidence interval. Go down to the bottom is the z-score, 1.96. So on the left, on the right, critical value z-score is negative 1.96. On the right is positive 1.96. The two are critical values. Now find out the test statistics. Test value. Test value is x bar 78 minus mean 75 over standard deviation 10 divided by square root of n, it's 50. Figure out is 2.1213. So z-score is 2.1213 is greater than 1.96. Greater than is to the right of 1.96. So it's falling in the critical region. It's falling in the critical region, so reject H0. Reject H0. Reject this claim H0. So the test value is 2.1213 falls into the rejection region, critical region, since 2.1213 is greater than 1.96. So we reject the null hypothesis. Reject null hypothesis. So therefore, the claim is null hypothesis. So there is enough evidence to reject Dr. Kaufman's claim, the claim that the average number of calories in a serving of popcorn is 75. Then question 5. According to the American Pet Products Manufacturers Association, cat owners spend an average of $179. That's the mean. Mean is $179 annually in routine veterinary visits. A random sample of local cat owners reveals that n equals 10. 10 randomly selected owners spend an average. So sample mean from 10 owners, figure out average is $205. This is X bar. And S, so this question, the population standard deviation is not given. Give you sample standard deviation is $26. And question asks you, is there a significant statistical difference? So it's not equal at alpha equal 0.01. So do not ask you less than or greater than, you find out difference. So this is not equal. So this is a two-tail test. Alpha equals 0.01. And for the traditional method, you have to do the 5 steps. First step, state the hypothesis. Null hypothesis H0 and the H1 alternate hypothesis is which one. Identify which one is the claim. Second one, find the critical values according alpha. Find critical values. The third step, find the test values. Test values, you have to decide is t-test or z-test and or chi-square test. Step 4, decide whether reject H0 or do not reject H0. Null hypothesis. The fifth step, summarize the results. Write down the conclusion. So, question 5. Here say, mean is $179. N sample use 10 samples. Mean average is 205. Sample mean is $205. Standard deviation $26. Alpha significant level is 0.01. And the degree of freedom is n-1. 10 minus 1 is 9. Since the population standard deviation is unknown, so use the t-test. So then we draw this normal distribution. Here, first of all, we have to figure out H0. H0 is mean equal $179, and the alternate hypothesis mean is not equal $179, and that is the claim, because questions say, is there a significance, statistical difference? Your claim. So that's the claim is not equal, not equal. So that is difference, not equal $179. That's the claim. So it's because alternate hypothesis is not equal. This is a two-tail test. If alternate hypothesis is less than, that's left tail test. If alternate hypothesis is greater than, and that's right tail. If H1 is not equal, two tail. If H1 has this, that have this symbol less than, is left tail test. If H1 have greater than, is a right tail test. If H1 has not equal, that's a two-tail test. Two-tail test means alpha go two-tail. Since here alpha is given, is significance level is 0.01. Alpha equals 0.01. Alpha equal here 0.01. Then you divide it by 2. So each tail is 0.005. 0.005. Add together is 0.01. So it's 1%. Subtract from 100%. So confidence interval is 99%. So use this table on the 99% confidence and go to the bottom on 99. Oh no, this is the t value. Because S, so we have to use degree of freedom. It's 9. So 99% degree of freedom, it's 9. 99%. Intersection, this value, 3.250. So you got T critical value, T alpha over 2 is negative 3.250. And the other side is positive 3.250. Those is a critical value for T score. T score, because S sigma is unknown. So we have to use T. So then that's critical values. Then we figure out the T value, T score. Test value is X bar minus mean over S over square root of N. Mean is 205 minus population mean is 179 divided by standard deviation 26 divided by square root of N. N is 10 and figure out 3.162. 3.162, it's here is less than 3.250. So is to the left of 3.250. Here is 0. And this is 3.162 is less than 3.250, is to the left of 3.250, is falling in, not fall into the rejection region. If on the two sides, on the right and the left of critical values, that's a rejection, critical region, rejection regions. So it's falling in, not falling in. So then you do not reject H0. Do not reject H0. So this question is a conclusion. Do not reject null hypothesis H0. Because in here is do not reject H0 between the two critical values. Test statistics between the two critical values. Do not reject H0. And if falling in critical regions, that's a reject H0. So do not reject H0. Do not reject H0. That's accept reject H0. So it's reject H1. So this is not enough evidence to support the claim. The claim that the average expense differs from $179. So it's not do not reject H0. That means do accept H0. So do not support H1. So it's not enough evidence to support the claim that the average expense differs from $179. And the question 6, a recent survey found that 8.6%, so that's the population proportion, P equals 0.686 of the population own their home. Population have 68.6% own the home. So that's the proportion for the population, P equals 0.686. In a random sample, N equal, so P equals 0.686, N equal 150, head of household, 92, X equal 92. 92 responded that they own their home. So you do P, population P is 0.686. Q is 1 minus P, 1 minus 0.686. And you will get Q is 0.314. And then sample, out of 150 have 92. And divided, you will get sample proportion P hat equals 0.613. So it's 61.3% in this sample on the home. In population is 68.6%. In this sample, 180 house figure out is survey figure out is 61.3% on the home. And question asks you, at alpha equals 0.01 significance level, does that suggest a difference from the national proportion? Difference, so it's not equal. So this is a figure out H1 is P not equal 0.686. Equal is always for H0, not equal is for H1. And that is not equal. Difference means not equal. That's the claim. That's the claim. So then we figure out the because it's not equal, so it's going to be two-tailed test. If not equal, two-tailed test. If this H1 is less than, that's left-tail test. If H1 has greater than, that's a right-tail test. Now, if not equal, it's a two-tailed test. That means alpha go two tails. 0.01 divided by 2. So each tail is 0.005, 0.005. And so 1%, subtract from 100%. So confidence interval is 99%. And 99%. And since this is a proportion question, you always use z-test. So you look at 99% confidence interval, go to the bottom, find the z-score is 2.576. So on the left, negative 2.576, and the right is 2.576. The two are critical values. Figure out. And then you figure out the test statistics. Test value. Test value, also called test statistics. And this side, and you will use the z, proportion z. This one is test value, sometimes called test statistics. Z equal p hat minus p over square root of pq over square root of n. P hat is here, figure out, is 0.613 p hat minus q. Q is 0.686 minus p. P is 0.686 divided by square root of p. P is 0.686 times by q. Q is 0.314 divided by n. N is 150. Take square root. Use calculate. Figure out this is net 1.93. Net 1.93 is compared with critical value negative 2.5576. Test value z equal negative 1.93 is greater than negative 2.576 critical value. So it's fall to the right of this critical values, to the right of critical values. So it's not falling into the rejection region. So this is do not reject H0s. Do not reject H0s. So do not reject the null hypothesis. And the question is this. So do not reject null hypothesis. That means support null hypothesis will not support the H1. So there is not enough evidence to support the claim that the population of homeowners is different from 68.6%. And question 7, a lab technician is tested for her consistency by making multiple measurements of the cholesterol level in one blood sample. The target precision is a standard deviation. Standard deviation is 1.0 milligram per deciliter or less. If 10 measurements, n equal 10 given, are taken and the standard deviation s equal 2.1 milligram per deciliter, is there enough evidence to support the claim that her standard deviation is greater than the target? So H hypothesis H0, the standard deviation is 1.0, the target is 1.0, and the greater than the target is greater than. So H1 is sigma greater than 1.0. That's the claim, because one claim greater standard deviation is greater than, so sigma greater than 1.0. That's the claim. And since this point to the right, so this is a right tail test. So and you will use the chi-square distribution, chi-square curve. The chi-square is square, so it's for the variance and the standard deviation is totally to the right of 0 because it's all positive. And now this is greater than, so it's a point to the right. So it's greater than, it's point to the right, so it's a right tail. So alpha fall to the right tail. Total is 0.01. Alpha is 0.01. Total fall to the right. So alpha equals 0.01 on the right tail. And then you can use alpha equals 0.01 and use the you can figure out this critical value. This is a critical value. And use the chi-square table. Degree of freedom is 9. Use chi-square table, and alpha equals 0 because chi-square table is given alpha here is to the right of the chi-square is the alpha area. Now here this area is 0.01. You can figure out the chi-square right side, and the 0.01 is here 0.01, and degree of freedom is 9. So look at 9 and 0.01. You got this one, 21.666. Got 21.666. That is the critical values. And then figure out the test value. The test value is chi-square value. The chi-square value is use the formula. The formula is on here. Chi-square test for the variance and the standard deviation is equal degree of freedom times the ratio between the variance of sample and the population. So it's going to be this n-1 is degree of freedom and ratio between the variance of sample and the population. So it's n-1 is 9. S equal 2.1 from page. S is 2.1, and sigma is 1.0. Plug it in. 2.1 square. Sigma is 1.0 square, and figure out is 39.69. 39.69. It's over here. It's greater than 39.69 is the test statistics falling to the right of 21.66. So falling into the rejection region. So this is a reject H0. So since the test value 39.69 falls into the rejection region, since 39.69 greater than 21.66, so we reject null hypothesis, reject H0. And the question wants you to figure out, this is the claim. So we reject H0. We reject H0, that's we support H1. So there is enough significance evidence. So therefore, there is enough evidence to support the claim that because original claim is greater than. So is support the claim that her standard deviation is greater than the target. Target is 1.0. Question 8. And using the chi-square table, find the p-value interval for the test value. Test value, this is a test value. This test value is chi-square equals 13.974. Find this test value's p-value interval. N equal 28. Sample is 28. Two-tailed. So first of all, we figure out the degree of freedom, n-1. N is 28, minus 1 is 27. 28 minus 1, and you got equal 27. And then using the chi-square table in the row, chi-square table in the row of degree of freedom is 27, and find the two values such that the test value is 13.974. Test value is 13.974, and find falling between two numbers. Let's look at the chi-square. Degree of freedom is 27, this one, and the number is chi-square here given number is 13.974. 27 13.974 is falling between the two number, 12 and 14. So when degree of freedom is 27, 13.9 is between 12 and 14. So falling between the two number, 13.974 is falling between 12.879 and 14.574. And then you look at the area, because you are looking for this one, and this is a chi-square curve, and 17, if here is a chi-square left equals 12.879, and you're looking for this area, and with the degree of freedom is 27. So you look at the table, 27, degree of freedom is 27, and this number 12.879, and go to the top, to the right, the alpha is 0.99. So this area is 0.99. To the right is 0.99. And then to the left is 0.01. 0.01. So minus. So 1 minus. So area to the right of 12.879 is 0.99. So the area to the left would be 1 minus 0.99 is 0.01. So this area is 0.01. This area to the left is 0.01. Because p-value is 2 tail, so we have to figure out to the left of those values. So it's 2 tail. P-value is 2 tails. Now then the area to the right of the other number is 14.573. So you look at this chi-square, this chi-square distribution, and the other one is 14 chi-square left is 14. The other one is 14.573. Use degree of freedom is 27. And looking for the table, degree of freedom is 27, 14.573. And move to the top. And figure out alpha is 0.975. So is to this area is 0.975. So to the right is 0.975. And so the area to the left is 1 minus 0.975. So this area is 0.025. 0.025. Now this number is between the two numbers. So to the left of this number also between 0.01 and 0.025. Therefore, the area to the left of 13.974 would be between the two number 0.01 and 0.025. Now, the p-values is the sum of the area in 2 tail. The p-value, what is the p-value? Is the sum of the area in 2 tails. So each tail have the same area. Now you only figure out one tail, so double it, that gap p-value. So the p-value is between double. 0.01 times 2 is 0.02. 0.025 times 2 is 0.05. Area in one tail is between 0.01, 0.025. I figure out the left tail is between 0.01 and 0.025. And also have a right tail. The right tail is same as left tail. So you double it. So area in 2 tail is a p-value. So double it. 0.01 times 2 is 0.02. 0.025 times 2 is 0.05. So next question is medical research is interested in whether patient left arms or right arms are longer. If 13 patients, so n equals 13, give the degree of freedom. Degree of freedom is n minus 1. How many degree of freedom? So it's minus 1, you got 12. 12. So answer is 12. And type 1 error, type 2 error. Type 1 error is if one rejects the null hypothesis when it is true. When it is true, you suppose should be accept it, do not reject it, but you reject it is wrong. So it's a type 1 error. And type 2 error. Type 2 error is the one occur if one do not reject the null hypothesis when it is false. When the null hypothesis is false, and the one do not, it is false, you suppose should be reject it, but you do not reject it. That is a false. That's what we call is an error. We call type 2 error. If one do not reject null hypothesis when it is false. Because if a null hypothesis is false, you should reject it, but do not reject it. We call type 2 error. When null hypothesis is true, you suppose should